Calc 1. I'm your TA, Alex, and what I'm going to do today is show you how to do one more thing without a calculator. Let's say we have some function, whether it's a polynomial or a trig function or something. If you think back to pre-calc, what you probably did to find the coordinates of a maximum or a minimum point like this is use your calculator. With the TI-83s or 84s, remember that left bound, right bound guess deal? What we're going to do now is use calculus to find the coordinates of these points without using a calculator. So I'd like to do this by way of an example. If we have f of x is the quantity x minus 4 squared, who can qualitatively describe what this graph would look like to me? Ben?
It's a parabola.
Okay, we have a parabola.
Opens upward.
It opens upward, good. And where would the vertex be?
X equals 4.
Alright, cool. So we just have a shifted parabola. Vertex is over here at 4, 0. It opens up. So just by inspecting our graph, or if we can just look at the function and determine what it would look like, we know that we have a minimum right here at 4, 0. So we'll go through the process now using derivatives to figure this out without looking at the graph, and then this will verify it for us. Now, what we know about this here is that if we have a function that's decreasing, for example, in this interval, this function is decreasing, your derivative is negative, right? And over here, where it's increasing, it's positive. So at these extreme points, at the minimum or the maximum, it's neither increasing nor decreasing. The derivative is 0. So that's basically the idea that we want to use to find the coordinates of the minimum or maximum here. So if we take our f of x, take its derivative, using our power rule, the 2 comes down in front, decrease our power by 1. We have a chain rule in effect here, but since the derivative of x minus 4 is just 1, it's negligible here. So if we simplify, our derivative is 2x minus 8. Now, like I said, we want to know when is this 0. So using simple algebra, we can add our 8, divide by 2. So we know that the x coordinate is 4. That's good, because that's what we said over here. Now, we know that x equals 4 is a point of interest. We call these critical points. But without inspecting the graph or being familiar with the function, we don't know whether it's a minimum or a maximum. So then what we have to do is turn to something called the first derivative test. So the function in question here is continuous over its domain, which is all reals. We only have one critical point here, which is x equals 4. So if we take this number line to represent all reals, mark our critical point, x equals 4. What we need to do is look at the interval to the left of 4 and to the right of 4 and find out what the derivative is doing there. So we can choose any point to the left of 4, substitute it into our derivative, and observe the sign. What's a very simple point that we could plug in here? 0. So let's take 0 here. We'll take f prime of 0, gives us 2 times 0 minus 8, negative 8. So what's important here is the sign, because everywhere in the interval to the left of 4 here, the sign of the derivative is going to be negative. Let's mark that. We can choose a point to the right of 4 now to determine this interval. Might as well go with 5. So we'll take f prime of 5 is positive 2. So every point to the right of 4 here will have a positive derivative. Now let's step back from the derivative, turn back to the function, and see what this implies about that. Before, just like we said, decreasing function has a negative derivative, increasing function has a positive derivative. So if we return to that, our function is decreasing here, hits a point, and then it's increasing. Well, our function was decreasing, it hit the point, it's increasing. That lets us know that this point is a minimum. So to summarize the rules for the first derivative test, if you have negative to positive, this is from left to right, then what you have is a local minimum. The opposite, positive to negative, that will give you maximum. And if you have positive to positive, negative to negative, you have nothing. So how could we come up with an example of that? Well, one of the most common ones is, let's say g of x is x cubed. If you look at this, at x equals 0, this is one of those examples where the derivative is 0 at that point, but you can see it's increasing on this side, it's increasing on this side, it would be positive to positive, so it's neither a minimum nor a maximum. And if you wanted to explore that further, if we were to take the derivative of g of x, that's 3x squared, and you can see that whether x is negative or positive, it's squared, so your derivative will always be positive here. So, that's that. Are there any questions? Okay, then thank you for your time.